Welcome back to the channel. Today I'm talking about embracing the cloud. What is the cloud, how it can help you, mistakes to avoid, and other stuff. Let's get into it. So what am I talking about today? Well, I'm talking about the cloud and DevOps, and specifically how DevOps has sprung out of the cloud, or did the cloud create DevOps? Who knows? I'm also going to talk about infrastructure provisioning, because an important part of the cloud is defining the infrastructure, as well as serverless computing, because there's no point having the cloud unless you can use serverless. We don't want to look after servers, right? And then there's managed services. More about that later. But what does it mean to you? Well, I looked this up and it says cloud computing is using someone else's hardware. Essentially, everything that's not on-prem is public cloud computing. There's also another term called private cloud, but we're not going to talk about that today. The rise of the cloud. So before AI and before Kubernetes, Amazon Web Services was created in about 2001. Yes, that's a long time ago. Yes, I'm older than that. They created it first with S3 service, which is a way of storing data securely with maximum nines and all that sort of stuff, so that it doesn't go walkabouts. In my book, Who Moved My Servers, I talk about keeping the data safe, and that's very important, and that's exactly where Amazon started. Shortly after that, they developed the EC2 service, Elastic Compute Cloud, where you can on demand ask for a virtual machine. Now, this is back in 2001. And like I said, this is before AI and before Kubernetes, and even before serverless was a thing. But why does this matter? Elastic this and elastic that. Well, the whole point of Elastic is being able to pay or spend or buy exactly what you need. If your application is running fine on one server, only pay for one server. If on a Friday at 3 p.m. it suddenly spikes, and you need to do everything on that server because all of your customers want their stuff done before the weekend, oh my god, you need 4 servers. Now traditionally, if you're running servers on-prem, you would have to have those 4 servers all the time. But the advantage of having the cloud and the elasticity, hard for me to say, the elasticity of the cloud is where you can borrow somebody else's servers for when you need them. In our example, at that 3 o'clock point on a Friday, we just borrow more servers. We've got 4 servers running along, and then by the time we get to 6 o'clock and everyone's down the pub, we can spin all those servers down again except one, and everything's happy for the weekend. Hardly everyone looks at it the weekend, it's fine. But we've been able to service those customers to get done what they need to get done before they go down the pub. But what else does it mean? Well, in order for us to be able to spin servers up, they need to be active as quickly as possible. It's pretty pointless having a server if you then take ages and ages to build it. In the olden days, when you had to use CD-ROMs and before that floppy disks to build servers, it could take days to build a server. Now with cloud and internet and online networking, we can get that stuff down to 5 minutes. Sometimes even less, depending on how much stuff we need to load onto the server. The impact of that, of course, is that servers build quickly, and as soon as you want it, it can be there working for you whilst you're paying for it. Also with public cloud, they want us a way to spend our money. Therefore, they want a self-service portal so that we can request the servers that we want. After all, they can't start billing us for a service until they've delivered it. So making that as easy as possible for us customers is exactly what Amazon did in the early days. Want a server? Click, click, click. Here you go, there's a server. And now with tools like Terraform, we can do it even faster than that. The downside of this, of course, is that on-demand computing costs money. I've done another video in my channel, the link is in the description, of why do AWS servers cost so much money. The short answer is, whilst that server's there and you're not paying for it, somebody's got to pay for it. So there's a balance there. Ultimately, if you want the server to be available, somebody's got to spend money to pay for that, and Amazon don't want anybody except the customers to pay for it. So the cost gets spread. And then this led to the next revelation of cloud computing, which is pets and cattle. You may have heard this. I think it was actually a Microsoft person that coined this term. And that's where, in the olden days, you have a server. It's taking you ages for it to be shipped from the supplier. Then you've spent a couple of days building it. And then you've nursed this thing because it's got redundant power supplies and redundant CPUs and redundant this, that and the other, because it's the only one you've got and you don't want it to die. It's your pet. The cloud kind of spins that idea on its head. If you can have a server up and running that you pay for on demand within 5 minutes and it's working for you, as soon as that demand disappears, customers down the pub if you remember, then we can switch the server off. And therefore it's like cattle. You raise the cattle, it's useful for a time, and then you kill it. Bit brutal, but that's it. If you can automatically build your servers, you don't need to treat it like a pet. So where do we get these servers from? The provisioning of servers. Ultimately, it comes from the Cloud API. Whether you're using Linode or AWS or Azure, they all have APIs where you can request the servers that you want. I'd like a server with this much CPU and this much memory, please. Oh, and can you bolt a couple of disks onto it? You can request all of that through their Cloud API. But Cloud APIs can be a little bit clunky and they change constantly. If you don't believe me, just look at the Terraform AWS provider that's being updated almost on a daily basis. Then, to help us out there, is configuration management. What does configuration management do? Well, once the Cloud API has been called and it spins up the server, we then need to configure that server. So step 1, get the server, a bit like ordering the hardware. Step 2, configuring the server, loading the operating system, loading all the software, configuring it with all of the settings it needs, who's allowed to log onto it, user accounts and all that sort of stuff. Well, that can all be handled by configuration management. Configuration management tools like Puppet or Chef, or these days everyone's using Ansible. You load all your configuration in there, the server spins up, it goes, what's my configuration? You pass it an Ansible playbook, it spends a couple of minutes configuring it, done, it's up, spinning, ready to go, ready to work for you. And if you're going to bundle the API together in Terraform modules, and you're going to use Puppet or Chef or Ansible, then we're talking about configuration as code. I did a previous video in this series about configuration and infrastructure as code, so take a look at that. What tools can we use? Well, I've already let the bag out already, and I said cloud services. So we've got Azure, we've got Google, we've got AWS of course, and those will provide APIs and we can use our infrastructure as code in order to use those. But there's also other ways of accessing the cloud. I'm sure you've heard of Microsoft 365 or Google Workspace, and these are email, Office, Word documents, spreadsheets and alternatives like that. And those are also using somebody else's computer, so they qualify for the cloud definition. The software manufacturer, or developer as you might call them, they develop the software and they can sell it to you monthly along with the servers required to run it. They make more money out of you, you get more convenience, a win-win. And then there's serverless managed service. This is stuff like Amazon S3, as I mentioned before, are definitely servers, you haven't got to look after them. There's other things like the Google AI platform, Amazon RDS Aurora. There's a database service where again you don't look after the backend servers. GitHub Actions, that uses servers, you haven't got to look after them. Cloudflare, for your WAF requirements. And a CDN. Again, all of these use servers and none of them are available to you to touch directly because you don't need to look after them. But they are serverless and they are cloud services. So how do you get to using the cloud? Migration. And the scariest thing you can say to any engineer is lift and shift. Don't do that. And if you're going to lift something and shift it somewhere else, you might as well be running it on your own hardware in your own data center or that data rack in the corner of your office. You're not going to save any money because Amazon, as an example, will charge you a lot. They'll charge you because you're using their server hardware. They've got to buy that. You're using their data centers. You've got to pay for that. And then you've got to pay for the software development. Oh yeah, that too, that you're looking after and being able to access that server. So if you're just going to lift a server from one place to another, you're wasting your money. Keep it where it is. Chances are the server you've got it running on is more resilient. Because another thing that Amazon don't necessarily tell you is that their servers are cheap. This means they will fail. They've got no fail-safe on them whatsoever. The reason why S3 works so well is because it's thousands of servers all working together, all with replicated data. If one of those dies, it doesn't make an impact on the service. If you've got one server and it's running a service and it dies, it does create an impact on your service. If you're migrating a cluster, then there might be gains to be had. But ultimately, the main gain is not in lifting and shifting. It's by re-architecting your software so that it can automatically scale, follow the sun as the demand grows and ebbs and flows. So the big benefit of moving to the cloud is re-engineering your software or your server application so that it can take advantage of automatic scaling. This is so that it can ebb and flow with the demand, the high demand and the low demand during the day. And rather than having to pay for the peak number of servers that you need across that service, you can reduce that down and so only pay for what you need, which might make a saving on your total outlay. Of course, on top of that, you can also use managed services, so you haven't got to look after servers at all. If your database server isn't being looked after by you, and it also automatically scales, then that's two reasons why cloud computing can save you time and money. And if you're saving time, it means you're not paying engineers so much. If you're enjoying this content, then I'd really appreciate a like on the video. And if you want to go the extra mile, subscribe as well, because that really helps the channel. And check out more information on DevOpsAnswers.com. So what have I spoken about in this video? Mainly about cloud. We've got the cloud services themselves, AWS, Azure, Oracle, OVH, DigitalOcean, Linode, there's loads of them. And whichever one you want to work with, I mean, you don't even have to tie yourself with working with them. If you're using infrastructure as code and you're using tools like Terraform, then you can cross-blend this. I wouldn't recommend it. I would say stick with one platform for one service. If you want your servers hosted in one spot, use one service for that. If you want to be multi-cloud, as they say, then that's okay. But if you're using Microsoft 365 for your productivity tools and your email, and then you're using Amazon for your servers and your databases, you're technically multi-cloud, but you're not spreading the expense of having to have engineers that know everything about every cloud. That's going to cost you more and doesn't really give you a benefit. But with infrastructure as code, the choice is there for you. Stuff like Terraform can then link into all of the cloud APIs, and those APIs can then provision the servers. Once the servers are provisioned, you can then use configuration management in order to configure those servers, give them a personality if you like, and then get them starting working for you in as little as 5 minutes. Other tools, the managed services I mentioned, online office, collaboration, managed infrastructure like database, and of course these days nothing would go without mention without talking about containers. So if you're going to migrate and adopt the cloud, please don't lift and shift. It'll cost you more in the long run. Use the cloud features. Look at something like 12-factor apps, which will tell you the 12 factors that you can have for that flexibility and stuff within your application that will make it cloud ready. Any questions? Then put them in the comments below and I will love to answer those. And until next time, have fun and may all your deployments be smooth.